11, 12, and 13 all have to do with accuracy and precision. Over my 7 years of teaching, I've seen that you kids really expect perfection. Things don't have to be exactly right every single time to be fairly precise and accurate. You'll see what I mean in a minute. All right, so in this problem, we're given 3 examples, and we're just asked to determine whether something is accurate, precise, both, or neither. All right, so if I look at 11, each of 5 students used the same ruler to measure the length of the same pencil. The measurements gave these results. You can see those 3 measurements. Sorry, there's 5. I don't know why I said 3 measurements, and they're all pretty close to each other. And it says the actual length of the pencil is 15.5 centimeters. Using these numbers as examples, distinguish between accuracy and precision. All right, so this is a little bit harder question because you actually have to explain something based on data, which is actually what science is really about. So let's review. The word accuracy means how close to accepted value. All right, all of these people had 15.3 something. The pencil is actually 15.5. So I would say they are not accurate. They're 2 centimeters off. 2/10 of a centimeter. I guess that's kind of close, but I mean, this is a pencil. It's not very hard to measure. All right, so they are not accurate, but precision means how close together. So I would say that they are precise. Now, this is interesting. You don't have to explain this, but I want you to think possibly. If all the students are getting this problem, what is the actual problem in this measurement? Think about that for a second. All right, my hypothesis, and it's just whatever, who cares? If all of them were that close to each other but that far off, then there's obviously a problem with the ruler. All right, it must be a little bit short. Probably not their measurements because 5 people aren't going to read the same thing wrong. So it's probably the ruler. Okay, number 12, comment on the accuracy and precision of these basketball free throw shooters. All you have to say is if they're accurate or precise, both or neither. All right, number 13, it's similar. Now it says 3 students made multiple masses of a copper cylinder, each using a different balance. The correct mass of the cylinder had been previously determined to be 47.432. Describe the accuracy and precision of each student's measurement. All right, so you're going to compare all of these to 47.432 grams. Jim, he's 47.13 all this way to 46, 94, 47. He's kind of all over the place. And they're all 47s and they're all fairly close to the accepted value. All right, Randall is all 47s, but he's quite high. So Jim's all over the place, so we're going to say neither because he was not too close to the accepted and none of his were together. We're going to say and, she's close together and close to the accepted value. So she's going to be both. And Randall, since he's not close to the accepted, but he's close together, we're going to say precise. Now, think about why we put those. If you're just copying these to your homework, you're kind of cheating yourself because you're going to have to do similar things to this on your exam. Make sure you understand why we put neither, precise, and both for these 3 examples.